So today we're gonna prove that root 2 is the irrational by not a classical method in which we assume that it is irrational, and then by contradiction. So we wouldn't do like that. Okay, we start with the equation which is x square minus 2 is equals to 0. Okay, we start with the equation with a simple equation. Okay. And I think you have read about the rational root theorem. Rational root theorem, okay, which states that if there is a polynomial an xn plus x an minus 1 xn minus 1 plus an x by 2 an x by 3 dot a 0 equals to 0, so the integer or rational roots of this equation, which means which make them putting on in the place of x makes the whole equation 0, is this is divisible by this coefficient, this, and this is divisible by this coefficient, means leading coefficient. This is factor of leading coefficient, factor of leading coefficient, okay, and this is factor of constant term, constant term, okay, remember. Now in this equation we say that x square is equals to 2. Now square rooting both sides, we come up with a solution that x equals to square root of 2. Now as the integer root theorem states that, okay, as the integer root theorem states that the if it is an integer root or a rational root, if it is a rational root, if it is a rational root, so it must divide, means it is a factor of this and this. But we know that root 2 doesn't divides 1 and doesn't divides 2, which makes and shows that it is not rational. If it is not rational, so it is irrational, okay, irrational, which proves that proves that it is irrational, okay, which proves that it's irrational. Now we're gonna study the classical proof of this. We assume that it is a upon b form, where a and b GCD means greatest common divisor is 1, means they are co-prime, okay, they are co-prime. Now what we does that we assume that it can be rational, so we when we assume, so it can be written as that where a and b are integers and b does not equals to 0, okay. Now we square both sides, so we will get like this something, and then we will multiply both sides with b square, so we will get like this something. Now if it is multiplied by this, so it must be a square must be even and this must be also even, so we assume that it is even, and b a is divisible by, means a is divisible by 2, okay, a is divisible by 2. Now if a is divisible by 2, so a can be written as 2k. When a can be written as 2k, so we do that, okay, plug in that. Now 4k square is equals to 2b square. Now we do this and this, so b square is equals to 2k square. Now b is also divisible by 2, means a, if it is divisible by this, so we says that it is also divisible by this, and if both have a common divisor, that is 2, and both is even, so we cannot say that a and b have GCD 1. And when we say that they have no GCD 1, so the assumption which we take means which we take that a the square root of 2 is rational, so we can express it in the form of two numbers which are integers and where GCD is 1 and they are co-prime. It is also false, which come up with the contradiction. So it contradicts the the assumption, and when it's a contradicts the assumption, so it states that and proves that it's irrational. Irrational. Now there are not only this type of proof, not only this proof, only not this proof, only not this proof. There are numerous ways. There is also a geometric method in which we say that there is a rectangle and arc, and then we continue to that proof, but that's too long. But I would suggest that this is a classical proof. If you will do this in a board exam, so you will get marks, and it is an advanced mathematics, not a classical proof, not non-classical proof. Classical proof. Okay, non-classical. Now we can also do like this proof that see the integer the rational root theorem statement is why that is okay, why that's true, because see, here is x square minus 2 is equals to 2 is equals to 0. Now we can say that we take this here, okay. Now here is coefficient 1, okay. We know that it is something as integer, something like integer, and we know that it doesn't have only square root of 2, it has positive negative square root of 2, okay. That's